Yeah, so I'm going to talk about sustainability, and this is kind of a scary word at the same time as it is a very popular word these days. But I hope that with this session I can give you some food for thoughts and maybe help you think about the sustainability aspect when you get back to your projects, when you get back to work, when you're going to talk with your customers and other teams. And maybe you would be more aware about how sustainability aspect can come into the world of Kubernetes. Apart from being an organizer of Cloud Native and Kubernetes Oslo group, I do a bunch of different things. So if you really have something cool to share, but you feel shy to stand on the stage and kind of speak to people, you're welcome to join the Kubernetes Unpacked podcast, where I'm a host together with Michael Levon. And there we just invite guests to share to talk about some cool topics from the Kubernetes universe. So if you would like to be a guest on one of the future episodes, just let me know. And apart from that, I like Kubernetes, as you can see, and I like sustainability, both in my private life and at work. We have been hearing a lot about sustainability, and there is a lot of information out there in different forums and different channels. And for those of you who have been at the KubeCon and Cloud NativeCon EU conference in Amsterdam in April, you might have seen that quite a few sessions on sustainability have been the part of the agenda. So we can see that this topic is up and coming. And if you have heard about the Open Source Summit that is also arranged by Linux Foundation and CNCF, there is even a separate track on sustainability in tech and cloud native space. But with all this amount of information, it can sometimes be difficult to separate facts from fiction, since this has become kind of a buzzword. But we are technical people, techies, and we do like facts and statistics. So this is what I want to use as part of this session. We have been on this journey of monitoring the climate change and the overall weather conditions on our planet for a long time, for hundreds of years. We have started by measuring temperature on weather stations and on ships since 1800. And from there, we have been measuring surface temperatures from satellites and analyzing geologic records for signs of climate change. And all the data that has been gathered tells us one story, that the Earth is getting hotter. And there is an almost 100% consensus among the scientists that human actions and human expansion since the Industrial Revolution has caused this temperature increase and climate change. And since the 1800s, we have increased the amount of CO2 that is being emitted into the atmosphere with 50%, and it has never been as high as it is now, with almost 86 billion, I think, in the atmosphere. Brain freeze, sorry. In 2015, there has been a conference with 196 countries where they have unanimously agreed that they will do everything they can in order to keep the temperature increase beyond 1.5 degrees Celsius. And as we have experience with feature development, we know how time estimation and work estimation can be quite challenging. And in the reality, the same promises that have been made there have been challenging as well. And the Intergovernmental Panel on Climate Change that has released a report in March, where they had the final climate crisis warning, where they had gathered all the research and analysis and shared it with the public. And what we have learned from that is that with the currently implemented measures, we are not on target, and we will not be able to keep that temperature increase beyond 1.5 degrees. So the window of opportunity for us to make an impact is changing, and it is closing really fast. And that's why I think that every one of us here has a role to play in this, and together we can make an impact. But some people out there, and maybe some of you here may, and also my skeptical cat Penelope, which you can see on this photo, may be wondering, but okay, what does all of this have to do with tech? Isn't tech part of the solution? Isn't tech just sustainable by default? And yeah, tech can be a part of the solution. And with cloud computing, with artificial intelligence, we can actually reduce the amount of total emissions with 20% towards 2050. But this can be done on one condition. If we implement those technologies, operate them and use them in a sustainable manner, if we find ways to also help the consumers, the users of our products and our platforms, to also produce as little emissions as possible. And this has been serious science, so I want to run a quick quiz with only one question on my favorite topic, which is Kubernetes. So if you have heard this question before, don't scream it out. So I would like to hear from those who maybe haven't heard this question before. How much underutilized compute capacity is there on average in percent when it comes to Kubernetes clusters? What do you think? 60%? Well, 99. We are not doing that bad. Yeah. 78%. Wow. Okay. Yeah, that's quite. Right. That makes sense. Yeah, starting with big ambitions, that sounds familiar. But yeah, monitoring this could be a really good idea. And it's actually not that bad, like you mentioned, but it's, according to one of the research, it's more than 30%. So Cast AI, which is a cost management solution, they have been doing an analysis where they analyzed all the customers that are using their products and have connected their Kubernetes clusters to the tool. And they have identified that the amount of underutilized capacity on Kubernetes clusters for those hundreds of customers that they have has been more than 30%. And they have done some work together with those customers to reduce the amount of underutilized capacity. And they were able to reduce it by almost 30%. And what they calculated this to be a result of is almost $1 million of cost reduction in total. And in addition to the cost reduction, there is a good advantage here as well, which is the more efficiently used resources, which means that the Kubernetes clusters that the customers are running are also more sustainable. And that cost reduction that you may get out of this simple action, you could actually invest in some also actions to further improve the efficiency and greener usage of your Kubernetes clusters. And this does not, this sounded really serious until now, but this does not mean that all of us are unsustainably lost together with our clusters. But I think it is worth to have it in the back of our heads and take a look at what we can actually do in order to improve the sustainability state of Kubernetes. And as in many areas, this is a layered approach and there are multiple actions we can take, but it all starts with awareness. And I myself have not heard that sustainability is being mentioned that often in platform engineering, in software development in general. And I haven't been thinking about sustainability that much myself until in one of the projects where we have been working with our customers, we had public sector customers, and they started challenging us because they were invested into looking into their supply chain and looking into how much emissions are being produced by both their tools and also the software and services that they're using from the third-party providers. And that's when the mindset started changing. That's when we started looking into the sustainability aspect of our own Kubernetes clusters, of our software, and integrating it as an equally important requirement when it in our software development lifecycle. And first of all, we were few who were doing this, but with time, we were more who kind of started to change in the mindset and thinking about it as well. And this is kind of the reason for why I would like to spread awareness about it and show that there are some actions you can do that can make it possible. And we hear a lot about shared responsibility model when it comes to cloud, to public cloud. But I think that shared responsibility model can also be applied to the sustainability aspect. And here Red Hat illustrates it pretty nicely. Depending on which role you have and where you are running your Kubernetes clusters, you may have different level of access and power in order to affect the sustainability aspect of infrastructure. But most of us have enough power to affect the efficient and sustainable usage of resources that are running on that infrastructure and therefore make our solutions more efficient. And there are a few areas that I would like to mention, and maybe if we'll get time, I can show you a quick demo of relatively new tools that look really promising that can help us do some improvements in that area in our Kubernetes clusters. But the first area is kind of the area of supply chain and also where we are deploying our Kubernetes clusters. And this we can do a lot when it comes to the supply chain, from choosing the public cloud provider to choosing the data center provider for private cloud solution, to choosing a new library for operating your ecosystem or in introducing new functionality in your applications, introducing sustainability as a part, as an equal requirement in evaluation of what choice you're going to make, what kind of cloud provider you're going for, what kind of data center provider you're going for, what kind of library you are going to choose. Thinking about sustainability can also help you make more efficient choices. For instance, in the cloud native space, we are currently doing work into measuring the efficiency of the open source tools, which with time you can use this information also to make better choices. When it comes to public cloud providers, they are doing a lot in order to report how much emissions they produce and what kind of sustainability actions they take. But I would also like to mention the private cloud data center providers, which are doing a lot of cool stuff in terms of creating climate positive offerings. And for instance, we have one in Norway that is certified with Miljø Fyrtårn certification, which is kind of very good and strict certification in terms of also using sustainability factor as part of it. So they're offering the green server hosting. But the one that is also very cool is Eco Data Center in Sweden. And what they are doing is that they're taking it a step further, and all the heat that comes, the excessive heat that comes from their servers, they're using it to power the Swedish cities and municipalities. And they're started with a small city called Thule. I'm never able to remember it. But now they're building Eco Data Center 2, which will take and power the whole municipality with the excessive heat that they will be getting from that from their servers. So I think this is very, very cool and very inspiring. And thinking about it also when you are making your choices could bring a lot of value also for us overall. But of course, we would need to remember that a lot is also advertising, and which is used in terms of greenwashing. So kind of making that due diligence and checking what of it is actually true, which has been promised by the different providers, is also worth considering. And when it comes to deployment regions, when we talk about public cloud providers, for instance, here is an example of from a tool called Cloud Carbon Footprint. It's an open source tool that uses information about the carbon intensity that is being reported by different public cloud providers in and kind of can visualize it for you to make better choices. So what you can see here is the heat map for Microsoft Azure regions, starting with light green for the cleanest, for the regions with cleanest energy, and to dark red with 4 regions with the dirtiest energy, which is not using renewable energy sources to power their data centers. And we are in Norway, so we are doing pretty good. But if you are using other regions, for instance, for your dev and test workloads, thinking about that aspect could also make you a better choice of where you are running your test and development workloads as well. And the other aspect, once we think about where we are provisioning our Kubernetes clusters, the next aspect is what kind of nodes we are running our workloads on and what kind of size they may be using. And as someone in the audience mentioned that you always start big, this is typically a very normal behavior, but you can use tools also, for instance, cost management tools like OpenCost or KubeCost that can come with recommendations based on utilization of your workloads and can help you monitor how efficiently you're actually using those nodes, how well are they utilized, and if there are other family types or other sizes that you could choose in order to utilize those servers, VMs even more efficiently. And kind of following on the oversizing aspect will bring a lot of value, and that's when the monitoring tools come into picture. And I also would like to mention spot instances because it sounds scary. There are still, I hear it a lot at least, that it's a bit scary to run spot instances because they can disappear at any moment. But I have actually recently read an article about one of the companies that has been running 100% spot instances in production. And I'm not urging you to do that, but I think it's kind of an interesting experience that has been shared with the community because it proves that it can be possible. And an advantage of using spot instances, at least for non-critical workloads, at least in dev and test, could also help you contribute to utilizing the resources that cloud providers have to their maximum capacity. And if you are not dependent on those resources being available 100% of the time, you can do a lot by just making adjustments like this in test environments. Only by doing it there, you can already have a big impact. And we tend to forget to clean up or ensure that we are utilizing resources in test environments efficiently. So I think this is totally worth thinking about it. The next thing I also want to mention is scaling. And here I mean also scaling both the pods where our workloads are running, but also the nodes. And thinking about the conscious scaling only what you need and when you need it can also help clean up the underutilized resources and use what we have to its max efficiency. And I have experience with, for instance, applications that are not necessarily 100% cloud native, typically in, for instance, lift and shift situations, and they can become quite heavy. Or like Marius mentioned, where you are using a larger base image that has a lot of unnecessary stuff that you actually don't use. But at the same time, it has larger size. It may have components that are using more resources than you actually need. And this can be an improvement not only from the security perspective, but kind of thinking about, can you move something out of your applications? Can you make some of the components independent services that can be scaled separately from the rest of the application that does not need scaling? Can also have an impact on how your resources are utilized. And also choosing a slim image, as the image that has less components and only what you need, will also have an impact as well, because then you will have more space to run more resources that are actually used according to their max potential. And I have also seen situations where we could, for instance, hard code the max amount of nodes that you want to be possible to scale to, and then a bug comes in one of the applications, which causes kind of a nasty result where the amount of replicas just starts popping up, and then you have at some point 100 replicas that are running due to a bug in an application. And this does not only increase cost, but it also increases the wasted resources that are being used. So thinking about how you could utilize the functionality of the scalers that are available for us in Kubernetes can also help using the resources consciously. And KEDA, as an event-driven scaling tool, is also a really, really great tool. And it has a bunch of different scalers that you could use to adapt the scaling behavior towards your application and how it actually behaves, which may be different depending on what kind of application you have. And what I think is cool and is up and coming is the carbon-aware scaling. And the tools you can see here, the logos of these tools, are the tools that just popped up recently in the last half a year, apart from Carpenter, of course, which you could use in order to work with kind of scaling your workloads depending on the carbon intensity and efficient usage of your nodes, and also the regions where your Kubernetes clusters are running. So the Carpenter, for instance, is the node provisioning tool that that is currently being discussed to be moved to the autoscaling special interest group in CNCF, which kind of makes it even more available and easier to use also for a broader open source and cloud native community. And then KEDA there has recently been announced a carbon-aware operator for KEDA at KubeCon, which you could also use in order to define what is the max amount of replicas you can scale your workloads to, depending on how dirty the energy is being currently produced. So you could actually have a carbon-aware workloads where you are doing more when the energy is greener and cleaner, when it's powered by more renewable resources, and then you could scale down to do less when the energy is dirtier. Also, tools like Kepler and Scaphander can be used to, for instance, gather the power metrics of the nodes that you're using in your clusters, and then you could use that data and feed it to machine learning models in order to create some forecast on the efficient usage of your workloads. And KubeGreen can also be used to scale your pods and, for instance, cron jobs, depending on a specific schedule, where you could also kind of scale down or turn off some of the workloads totally at specific dates and times. And probably, as I mentioned, one of the biggest changes you can make is cleaning up. Has anyone heard about the Scream test? Someone probably has, so don't tell it. Say it. No? Yes? A scream test is when you remove a service and then you wait until someone screams. And if they scream, that means that the service is still in use, so you bring it up. But if no one does, then it's probably never has been in use. And I'm not urging you to do this in production, but I think this illustrates a great point of that we still make quite a lot of assumptions about that a specific service or a specific application has been cleaned up, or we assume that it is used, but it's not actually used anymore and hasn't been used for a while. And if you have, even if you don't speak Norwegian, you have probably heard about the word dugnad. It's when once a year we all go out and start cleaning our surroundings to make it nice and clean and free for waste. And this is kind of the term that we could apply here as well. Using, once again, tools like monitoring tools, even like KubeCost, can actually help you see what workloads are not being used at all, and you can even automate this in orders that can help you clean up those workloads if they are not being active or not being used at all. So doing that dugnad on the regular basis could also decrease your cost, but it also can remove the amount of wasted resources and make room for more resources that are actually that will actually be used to their max potential. And tools like Keda, once again, can also help you scale to zero, which is also a great opportunity when there is no traffic coming in into specific applications. Looking into turning off clusters in dev and test, for instance. We have had in one of the projects the clusters that haven't been used in dev for 5 to 6 hours every day because people were sleeping at that point. So why not just turn them off? If you have a proper infrastructure automation in place, you should be able to automate this process as well in order to be able to turn on those dev clusters to make them ready when people get back to work, and then turn them off when they're not needed. We have been doing that, and it has worked really nicely, and it also helps you to test how your infrastructure automation process is working and how reliable that is. Yeah, well, you could also scale down depending on the scheduling on a specific schedule, for instance, when you don't want to turn off, but you want to scale down some of the workloads. And independent of how much we do when it comes to the Kubernetes clusters themselves, it all comes down to the applications. If we have applications that are not that efficient, that require lots of resources, then we will still end up in the need of using much more resources to be able to run those applications. If we have applications that end up in huge images, container images of several tens of gig in size, and I have seen that, if they have if they're not only hard to scale, but they're also using so much more resources than they can potentially use. So lift and shift, which is also often a recommended scenario, does not mean that by just taking the big, heavy, monolithic application, moving it to cloud, that it makes it sustainable by default. It doesn't. You would need to make some actions in order to make that application ready and really efficient. And here I also think that those of us who work with Kubernetes can also get back to the teams that are working with those applications and deploying them to those clusters if we obviously see that there are some opportunities here, that the application requires that there are some performance challenges, for instance, with the application, that it's a bit heavy. We could get back and get the dialogue going also with the developers. We see how it actually is happening there and then when the application is running. So we have some valuable input we can also get and bring back to the teams. And there are also some great guidelines on kind of green coding and link coding, where you could utilize specific techniques in order to build not only efficient application containers, but also create a code that is also efficient and uses less energy. And here are some of the examples that some of the screenshots I wanted to show you. This is from the tool, the Cloud Carbon Footprint, which is the open source tool that measures the carbon emissions that your resources in public cloud are using. You could also run it on-prem if you have private cloud, for instance, but you would need to implement some additional configuration in order to kind of provide that data that the tool could use to kind of calculate this emissions. And here you could see that I could also get the emissions breakdown depending on the data on the regions that I'm using and how clean the energy is in those regions. And I can also get some interesting humanly readable comparisons in terms of what does the emissions of my workloads actually equal to in terms of, like, for instance, flights or amount of planted trees that would need to be done in order to compensate for it. And here I could also break it down for every day so that I can see what's happening and, for instance, see a trend if it's on the rise. So what is happening there, why it's happening? Is there some problems with the energy, the way energy is produced in a specific data center, or is something happening in terms of resources that I have running in the cloud? And these are also some screenshots from KubeCost, which is also a cost management tool, but at the same time, it does provide some useful recommendations in terms of not only the ways you could optimize the cost, but also the ways you could optimize the efficiency of your Kubernetes clusters. And for instance, here you could see that the efficiency of the Kubernetes cluster that is specifically here is 7%, which is kind of really sad to see. So it means that something needs to be cleaned up there and worked further with. And it can come also with concrete recommendations, like what can you do? You can right size your cluster nodes, and then it will come up with suggestions in terms of family type that you could use for the specific nodes. And it could flag the workloads that are not receiving any traffic, or the nodes that are underutilized. So you could dig into it and see what improvements you can make. And here you can also drill down more into the specific family type of a node that you can switch to, and how much more utilized that nodes would be if you switch to those based on the trends of your workloads until now. And once again, here you also can play around with it and see if you would like to utilize the CPU and memory to a higher percent on those nodes. What can you do? Are there some nodes that you could drain and migrate the workloads to the existing nodes, and by that also remove wasted resources? So the tools like this can be really useful not only for cost measurement, but also for the actions you can take in terms of creating more efficient clusters. And instead of just talking, I also would like to show you two of these tools just to show some straightforward demos of how you could use some of the tools that I mentioned for scaling the workload. So I would like to show you the KubeGreen tool, which is an open source tool that can be used to scale up and down specific workloads based on the schedule. So what I have here, I hope you see it fine. Okay, or shall I? Yeah. All right. So if we take a look at this Kubernetes cluster that I have here, I have a namespace chaos_neon_cat, and here I have two replicas of a non-critical deployment and one replica of a critical deployment. It's critical probably because it's just one replica, so you can't delete it. But what it does have, in addition to this chaos_neon_cat application deployments, is KubeGreen. So this is basically a Kubernetes controller that also, after it is installed, it can provide me a possibility to configure a custom resource definition of type sleep info. So if we take a look at the way it can be configured, as of now, it needs to be installed in the namespace where the applications you want to scale up and down are running. But what you configure here is when you want to scale up and down, when you want to scale down your pods or cron jobs, which are currently the two resource types that it supports, and when you would like to wake them up. And also you could configure the time zone, and you can exclude specific resources from being affected by this policy. For instance, I don't want to touch the critical deployment of my very critical application. Therefore, I want to exclude it from here. So if we just try to apply it right now, so now it's 1931. If I say 1933, and then we want to get it to sleep at 1933, and we want it to wake it up at 1935. So if I apply it now, let's see. All right, then we will just need to give it a few minutes. Oops. And then we will see how it will scale down and up again. So while it will need to take a few minutes, I don't want to tell you bad jokes, so I will try to hop down to the other demo that I wanted to show you in the meantime. The second demo is I want to illustrate you how easy it can be to get started with playing around with this tool. And the tool I want to show you is the carbon-aware operator for KIDA. So this is very fresh. So of course, where you would make most use of it, playing around with it, is in dev and test. But there is a lot of active development ongoing, so we will see more of it coming. But it is, if you go to the GitHub repo for carbon-aware operator for KIDA, you can actually do it as simple as just creating a code space in GitHub, and then you could just open it in Visual Studio Code locally or directly in the browser, like I would do. And then it sets up a code space that has everything ready configured in there for you to use. So what this operator basically does is that it can, if you want to play around with it, you can mock the carbon intensity data that is being reported by the different regions. Oh, I'm so lucky. Let's see. So it will, you can mock the data, or you could actually connect to the publicly available APIs like what time or electricity map, and then it will gather that information, and you can configure your different deployments and specify if the energy is dirtier, what is the maximum amount of replicas that I am allowed to scale up to, and when the energy is cleaner, what will the maximum amount of replicas be there, and then it will work together with the other scalers that you are using in KIDA and ensure that those are not scaling much more than you have configured, for instance, when the energy is dirtier. And then you could also use that metrics, that data that it collects based on the carbon intensity, and you can feed it into, for instance, Grafana. So if you use this code space directly, you could actually use the mocked data and just with a single command spin up a Grafana dashboard that would also show you how your configuration will look like in practice. So here is the code space that has all the source code ready for me to start playing around with that carbon-aware scaler. So if I just open it up a bit, here it will make a carbon-aware CADA scaler custom resource definition available for me. And if we will just look at a few things that are most important here is the carbon intensity forecast data source. This is where you would configure, for instance, the watt time or electricity map API that you want to gather the carbon intensity data from. But you can also configure mock carbon forecast property to be true, and then it will just make it easier for you to start playing around with it, and will just generate some mock data for you. Also, here in the max replicas by carbon intensity, you can configure if the carbon intensity that is being reported is 543 or less, then the max amount of replicas I want to scale up to is 15. But if it's between 543 and 561, I want it only scale to 8 replicas. And if it's 579 or higher, which is defined to be dirtier energy, when I want to do less amount of work, then I want it to only scale to 1. And then you could override that in some specific cases, for instance, in a specific time period or on a schedule with the eco mode section. And that would actually be enough. You would just need to run a make command, and I have already run it, and then it will build everything. It will install the client cluster, or you could also use the AKS cluster instead. Those are the two clusters that are currently supported by this demo app. And then you could just start up the Grafana dashboard because it will be prepared for you, and then you could see how it looks like. And it worked yesterday for me, obviously, but with the Wi-Fi I have some issues which I haven't managed to resolve until now. So I will just show you a screenshot of this Grafana dashboard, and here you could see what is the carbon intensity that is currently being reported from the region where your Kubernetes clusters are running. And then you could also check what is the maximum replicas, what is the default maximum replicas that are configured in case you want to override the carbon awareness. And also you could see what is the max amount of replicas that you have configured depending on the carbon intensity. And then you could see it changing in real time so that you could monitor how your configurations are looking like. So I will provide those resources and you could play around with it. It is just a few clicks and you are good to go to start testing it. And if we go back to our Kubernetes cluster, we could see that the non-critical pods have been terminated, and then they waited for some time and started up again, but critical pod was not affected. So you could use this tool for instance, turning off some of the workloads when you do not need them. It is pretty straightforward. All right, we are getting to the end of it. What I would like to leave you with is how you could actually get started and what are the tools and frameworks and resources out there that could help you to introduce or to think about sustainability aspect a bit more. It basically drills down to 3 steps. Define what you would like to improve in terms of sustainability in your Kubernetes clusters or in your applications. Then take a look at what tools you could use to actually measure that, and then based on those findings, how you can optimize it. And public cloud providers have introduced sustainability pillar in their well-architected framework where you could find some useful information, cost management tools, and also tools that I have shown you in terms of carbon-aware scaling could also help you to get an overview and improve the utilization of the resources. And there are quite a few tools that are, and also forums where you can go and ask any questions or get some help or advice, whatever you may be wondering about. For instance, the technical advisory group in CNCF for environmental sustainability, which I'm a part of, we are backing up a lot of those tools like Scaphander and KubeGreen and Carpenter, which I have mentioned, and we are doing a lot on kind of making those tools available and bring more value depending on how they are being used. So do check out that community. We're also sharing some resources, like for instance the sustainability maturity model and other resources that can be useful in this setting. And Open GitOps is another working group as well, where we are measuring, for instance, tools like Plux or Argo City, and we're trying to measure their performance and the efficient usage of resources to kind of see if there are any improvements that can be done in terms of making those tools more sustainable. And we would like to include more tools in the future and create a framework around it that can be used to actually measure the efficiency of the open source tools we're utilizing. And also, you can find all of these resources in the GitHub repo I'm going to share. But one more resource I would like to mention is the course for green software from Linux Foundation. It takes just a few hours to go through, but it kind of explains how the emissions are being generated by the tech industry, kind of drilling down into the specifics of how you could measure it, and also helping you to take the first steps to kind of understand why this is also important in your role in the company. And it's all about balance. Of course, it's easy to kind of get outside and say, you must do it this, and this way. This is not that easy when we come to the enterprise setting. So the whole point of what I'm telling you here is that it is a lot of value to just start thinking about it and making that as an additional factor when you are working with Kubernetes, when you get back into those discussions with software architects, with leaders, when you need to take new decisions, when you need to choose new tools, you can actually have an impact by just bringing it up, because it's not given that the others are thinking about it. And that's what I have seen. There are quite many people out there who don't necessarily think about it, but will be grateful and will be more aware if someone will take that first step and actually bring it up as a point in the discussions as well. And I think that every one of you can also make that impact. I have experienced it myself, that it gives a good impact when you actually start talking about it, when you start making that first step, starting with dev and test workloads, for instance, with those environments, and trying to see what can I do better there. And I would like to give you a challenge. Once you get back to work tomorrow or today, just do that dugnad. Take a look how your clusters are doing. Is there anything that is actually not being used or can be turned off? And if you would like to just spin up those demos to find out how you could use some of those tools, you can check out that QR code, because there it has all the resources that are related to what I have been mentioning today. And if you would like to talk about any of it, you can also reach out to me now or afterwards.